Hello and welcome, my name is Amir, and in this video we're going to create the Minesweeper game using React and TypeScript. The logic of this game is kinda simple. We have a grid of rows and columns. I think it's like 10 or 11 by 10 or 11 columns, but we can have bigger or smaller grid system, so it doesn't matter that much. And then we have a bunch of bombs or mines that are placed inside the grid, and we need to figure out their placement. So for example, if I click here, a bunch of these cells are revealed and I get a bunch of numbers here that shows the number of bombs around these specific cells. So for example, when I get to 1 here, it means that one of these 8 cells is a bomb, and while all of these are revealed, this will become a bomb, and I can mark it like this to know that this is a bomb. And then, for example, for this one, it has a bomb next to it, so this cell which is adjacent to this will not be a bomb. And then we continue going on until we resolve the placement of all the bombs or mines inside the map. So for each of these cells we have a bunch of values that we want to keep. First one is that, is it a bomb or not? The second one is that, is it revealed or not? So all of these are revealed, all of those that are grayed out, and all of these numbers are the ones that are revealed. Third one is that, have the user placed a marker on the place or not? So this one is placed a marker, so when a marker is placed, the user cannot click it to set it as a revealed one. They have to remove the marker and then click on it. And the next one that will become useful is the number of the bombs that are around a single cell. So for example, for this one, I need to find the number of bombs inside around it and set this one to 1. This will become handy later on. So let's go and start our project. So here in the sandbox that I'm using for this project, I would go here and say Minesweeper. I get an empty app ready for writing code. So first thing is that I would define a type for the cells. So here I would say type the ts, and I would define it here so that I can use it later on other components. It would be a type for the square, let's say t square or type of square, and it has, as I said, 4 different properties. Is it revealed, which is a boolean? Is it flagged or marked, which is a boolean? Does it include a bomb itself or not? Also a boolean. And then the number of neighbor bombs. So these are the values that I want for each of the square to be stored. Great, so done with the types. Let's go to the app here and then remove all of this stuff that are here and start coding. So I need to have a state to keep the squares or the cells inside so that I could render them and click on them. So let's call them squares, and then we would have a set squares as well, starting with an empty array, but this can be typed as like so. So a 2D array of t square. And of course we need to import it. So great. So first we need to instantiate this one. So I will define a function called let's say init, and it needs to return an array of the squares. So for now I would say empty, and here I would use the init. But to do the init, we need to do 3 things. First, I need to create the board, so the board as in 10 by 10 grid. Then I need to randomize and place a number of mines inside. And then when that is done, for each of the cells find the number of mines around it and fill that one in. So let's go here and say, first we need to create the board. So let's say squares create board, and we need to pass along some rows and some columns. So like so, and I can go here and say is for now 10, and cause is also 10, and number of bombs is also 10, or we can call it mines as well. So let's call it mines is also 10, but I need to define this function. So let me go into the here and have another file called helper.ts that would include these helper functions that we define. Let's have the create board in place. It will receive a rows which is a number, and cause which is also a number, like so, and it will return a 2D array of type t square. So we first go and say we need to have a new array of the length of rows. So we define our rows, we would fill it with null. Now for each of those cells we need to create another array. So we need to do the mapping, and in this map we will provide a new array again of the size columns. We would again fill it with null, and for each of the cells we want them to be having these values. So let me grab these. Now we need to map each of them, and I will have these values. Is revealed should be false. Is flagged should be false in the beginning. Has bomb should be false, and the number of neighbor bombs can be 0. And we need to have these in place. And I need to, of course, return this. Okay, so to make sure I can say this is of type t square, like so. Why I'm getting an error? It looks okay. So this type of object is not the same as t square. So let's go to this one, and so yeah, this should be a number. Now this should be okay if I refresh. Great, so this doesn't have any error. So let's go back to the app and define the create board. So the create board should be coming from the helper. I didn't export it, so here it should be export const. And now the app is happy. So now I have the squares, and if I go on it, it will say that squares is a 2D array of t square. Okay, great. Now that we initiated our grid, we need to place the bombs or mines on it. So let's say randomize mines, and it will receive the squares and also the number of mines. This should be let because we are reassigning it, and we need to write this function. So randomize shall go here, and if I go here, I need to say export this one, and this will receive 2 arguments. One is the squares, which is of type this, and the other one is the mines, which is of type number. and this of course is a const. Now what should happen with the randomized mines? I need to have like 10 different distinct numbers between the number that I have here up to the number that I have here. So if it's like 10 by 10, I need to have 10 different numbers between 0 up to 99. So there are a number of ways to do that, but I will use a set and then I will try to create number. And if that number is inside the set, it will be discarded by the set itself. So at the end I will have 10 different numbers. First, let me grab the number of rows and number of columns from this input that we get here. So rows is the squares dot length, and the columns is the squares of at index 0 dot length. Then I would have a, let's say, distinct numbers, which is a new set, and we can type it as number, like so. Great. Now, while the number of items inside this set is less than the number of mines that we want, we need to be inside the while loop. So now we create a random number. This will be between 0 and 1. Then I would multiply it by rows and by cols to be between 0 and 100. And then we floor it to be a full number like 0, 1, 2, 99. Great. Now I will add it to this set. Now if this number is already in this one, it will be discarded automatically, and we stay in the loop, in the while loop, until we get 10 distinct numbers. When we get that, we need to go into these numbers and put them inside the squares that we have. So I will convert it to the array, the distinct numbers, so that I can map over them. So for each, we need to find the row and column based on this number. So something between 0 and 9 will give us the row of 0. Something between 10 and 19 will give us the row of 1, and so forth and so on. For the columns, if it's 0, it's 10, it's 20, it's 30, 40, and so on. It will be the column 0, right? Because the remainder of dividing these values by columns, which is 10, will be 0. Only thing that I need to do is go to that specific spot and set the hasBomb to be true. And in the end, when this is done, I can return the squares. Great. Now if I go back to the app and here log the squares, and let me refresh it. I should see some row with bumps. Yep, this one has a bump. Great. So this is working. Now the third step is to get the bumps around the specific spot. So again, if I am here, I need to count the number of bumps that are on these three places and put it here so that it will show off when I click on this, as happened here. So I would have another function here. Let's call it get the mines around. Oh, by the way, I might use the term mines or bombs, but they are both the same thing. And for this one, we only need to get the squares. So what happens with this function? Let's go to the helpers, support const this one, and this will get the squares again, which is of type and then let's see what we can do. So obviously we need to go to here and start from here to here and then count the neighbors around it. So I need a for loop for rows and another for loop for the columns to get to each of the spots. So let me go here and say I going from 0 until squares.length, and then again the same thing for j. Now if the square that I'm on it is a bomb, then I don't want to count the mines around it because it's already a bomb, and if I click on it, the game will be over, the user will be lost. So like this. We don't reveal anything, we just lose if we click on the bomb. So we need to skip that here. We would go and say if that squares that I'm on at I and j, and it's squares. That's the beauty of using TypeScript, that provides us with errors. Now if I say dot, it will give me the properties that are already in the cell. So if this has a bump, then just continue. Otherwise, I need to count the bumps around it. So let bumps be 0. And then if I am, for example, here, I need to say, okay, this one, this one, this one, this one, this one, this. So 8 of them. So I can have 8 ifs for these ones, or I can have a for loop that starts from here, one row above it, until one row after it, and one column before it, and one column after it. So I need to have 2 more for loops here. Let's say this one is a k, and it will go from I minus 1 until I plus 1, and it will include the I plus 1. Same thing for, let's say, L is from j minus 1 up to j plus 1, and as we add to the L. Now I need to check if the cell at that position, at position k, L, has a bump or not. If it is, then we add to the number of bumps, and in the end, when the for loops are done, I can say that squares at I, j, the neighboring bumps is the number of bumps that we found. This works fine, but there is an error in this code. So please pause the video and try to find what's going on and what's wrong with this code. Okay, so I hope you have found the issue. The issue is basically this line of code. What happens? So for example, suppose that we are here. This position, both row and column is 0. So if I start from I minus 1, which is provided here, I would go here. But there is nothing here. So this is an empty or undefined. And when I want to, so this will be undefined. And when I want to get the L on this undefined, I will get an error as described here. So I need to check that. The easiest way is to do something like this. And also here. Now if this is a valid, then add 1 to the bumps. Now if I go and refresh here, you can see now I get the number of bumps that are around each specific cell. Great, so now we have the boards initiated. Perfect. Now we don't need this log anymore, and we need to just return the square, so it could be used here. Great. Now we can map on these squares that we get from this init. Here we can say for the squares that we have, map, we would get a row and a row index, like so. And we need to map these to a div. Let's say this div is of class name, not like this, class name of, let's say, row. And for now, let's have row index inside it and close the div, like so. Now I get the numbers, which is great. So next thing is that I need to provide the key, of course, for the each row. And then instead of doing this, we need to, for each row, show these cells inside it. So now we get each row and then map over on that one as well. This time I will get a square and then the column index for this one. And we would map to, let's say, another div, like so, and so do it like this and say the key is column index. What else we have? Let's give it some class name of square and then some data value for the number of bumps that it has. So square dot like so, and let's show the number of bumps here as well. Great, so 0, 1, 0, 1, 1, 1, 2, and so forth. So we are getting this. Let's get some CSS for this so that it looks like a grid. So let's go here into the styles and say row is of type flex. And for each of the squares, we need to have a bunch of styles. So first let's have the box sizing set to border box because we're going to use the border. Let's give the width of 30, the height of 30, the border top to be, let's say, 3 peaks, solid, and this color. Same for border left and border bottom and border right should get something like this color. Okay, perfect. Let's add some background. Like so. Okay, and let's place it in the center. Great. Let's add some font here as well. Let's go with this one. Great. Make it bold. Great. So this is our board. While at styles, let's add the style for colors as well. But the colors, I mean these ones, are only there for the ones that are revealed and has some value. So I will have some class that I will define later called square revealed, and let's say that here the border is now only 1 pix, it's solid, and it's let's say this. Now if I go on one of these and say this has the class of square revealed, great, so this is working. Now we can have the classes for the colors as well, for 1, 2, 3, 4, 5, 6, 7, and 8. And as you can see, this one is revealed. Now if I go and for example say this one is also revealed, let's say number of 3, this will become red as well. Okay, so fantastic, styles are working. Now of course I don't want to show the numbers to the user. Now the most important part is when I click on a cell and I need to reveal it. So let's go here and say on click we want to reveal, and I need to pass along which cell has been clicked, so the row index and the column index. Let's define it here, reveal, which will get a row index which is a number and a column index which is also a number. Now what would happen with reveal? So first, if I click on a bomb, the user is lost. So this is step 1. Step 2, if I reveal something and I click on it, nothing else would happen. Step 3, when I click on a spot that has 0 bombs around it, I need to reveal all the cells that are adjacent to that one. So I click here, this is 0, I need to reveal these 3. I would go here, this is 1, so I would put 1, and I won't reveal the things that are next to it. I will go here, this is 1, so I would just write 1, and I will not reveal the ones that are next to it, like these ones. Then I would go here, this is 0, so I need to reveal all the cells around it. Go here, I have already revealed this one, I have already revealed this one, This one is 0, so I need to reveal all next to it. This one is also 0, so I need to reveal all of the ones that are next to it, and I will go on. So first, as we said, if it's a bomb, user is lost. So if squares at row index and column index has a bomb, then alert, let's say game over. And to start a new game, we just reset the squares to the new init function, and then we return. Alright, now we get a bomb and we lose. Okay, so this is working. Now next step is that if it's revealed, we don't want to show it, reveal it again. So if squares at row index column index is revealed, we also want to return, we do nothing. Also, if it is flagged, so if I go here and now I flag this one, the revealing shall not work. So both this and so both of these cases we should return. Now, if it's not one of these, I need to do the recursive kind of thing, going from the clicked item, which is now a bomb, going from the clicked item all the way until I get to the borders where there is no thing to clear. So let me write it and you will understand it better. I will use a stack, and each time there is something that can be revealed, I will put it inside the stack. So let's say we have a stack. In the beginning, our stack is a array that will have a row index and the column index that needs to be revealed. Now, while there is something inside the stack, we need to reveal it and get the neighbors and reveal them. So we get the top of the stack, whatever is there, row index and col index from the top of the stack. So stack dot pop and this is like so. Okay, now this says that it might be undefined, but we already check it here, so we can say that we know this is not going to be empty, so this is fine. Now I want to say that this is my current cell, is these squares at index, row index and col index, like so. And if the thing that we popped is revealed, then we don't do anything. But if it's not revealed, then we need to do the thing. So if first we set this to revealed so that we don't go back to it again. Okay, now with this one, it means that when I go here, this will be revealed, and I want to reveal all of this. I will go here, I want to reveal all the ones that are next to it. So I will go back to here. If I don't check this one as revealed, this one will go and say, you reveal yourself, and this one will say, you reveal yourself, and this one will say, you reveal yourself, you reveal yourself. So we will stay in a never-ending loop, so to say. Here we would check that if the current cell that has bomb, if it doesn't have a bomb, and the number of neighbors is 0. Now we need to add non-min cells to the stack. So for all the ones that are next to it. So if I click here, all these 8s that are next to it. The same thing as we had with the helper function here. Here, when we counted the number of mines around. So here for let's say I, this is going from 1 before to 1 after. So to I is less than or equal to 1, and then we add to I. Then again for j from -1 until this and until j is being added. We need to do the check here. But first I need to get the number of current row or the new row, which is the row index plus the I. The same for the new call, which be the call index plus j. Now if we are still inside the cell, so if new row is greater than or equal to 0 and new row is less than the rows, and a new call is also greater than or equal to 0 and new call is less than the number of columns. If these are the case, then we are inside the grid. And also if the cell does not has a bump and is not revealed, so two more checks here, not and this does not is not revealed. When this big if is done, we can add that specific cell into the stack to be checked next. So we would push a row index, which is the new row. This is like this, and the call index, which is the new call, like so. And then when all of this is done, let's say we don't do it here and here. After the while is done, then we reset the squares to all the change that we did with the squares. Great. Add something to this class because we already have the CSS in place. So we can say here that this should be the square as usual, and it will be revealed only if it has the revealed, and it's like square. If this is in place, then it will be in place. This should be like this, and so on. I'm getting the full board here. Great, it's working fantastic. So I'm getting all these places. This should be a bump, and yes, it's a bump, and the game is over. Great, so now I need to put the numbers here as well on these spots. So in order to do that, we go into the revealed one, so square dot is revealed, and we would say if this is revealed, then check if it doesn't have any bump around it, then can show the number of bumps in the neighboring area. Otherwise you don't need to show anything. And yes, as you can see, these are being shown. Great. If I go here and refresh, fantastic. Great. This should be a bump. Yes, we lose. Great. So what's the next step? We need to put the flag. So if I go here, I need to be able to right click and put a flag here. So to do the right click, we need to define the onContext menu. And here set the flag, just like the reveal. But the context menu will always have the menu, pop-up menu here as well, so we need to skip this one. So I will pass the E so that I could use it later on there, and skip the right click. So let's go here, get the set flag. It will have three options, E and row index and call index. We need to type them. So this one is a number, of course. This one is also a number, but the E is of type React dot mouse event on HTML div element. Great. So now when this is in place, we can do this. So prevent the default on the event. Now if I right click, nothing happens on these divs, but here it happens, but not here. Great. Now if I go here and right click, nothing should happen. So if this is already revealed, then we return. Otherwise, we need to go here and swap the flag state. So if I go here and put the flag, and then next time I right click, I need to remove the flag. So here I would grab the squares from the state, reset the one that I want at that row index and column index. We set the flag to be the opposite of what it already is. And when this is done, we set the squares accordingly to the new squares, like so. And to see that, let's go here and say if square that we are in is flagged, then we need to show something, otherwise nothing. This flag start a new game. Now if I flag and I click, okay, now there is something wrong here, because when it's flagged I shouldn't be able to click it. So let's go to the reveal. Yeah, so it happens before this one. So I need to move this. So if it's revealed or if it's flagged, then we don't need to do anything with that one. Otherwise, we need to check. So now if I go here, if I flag, I cannot click on it anymore until I remove the flag. Okay, so this is resolved. Set flag is working perfectly. Now the only thing is that to know when the game ends. In order to do that, I would define a use effect that would check for whenever the squares has changed, or whenever we call the set squares, so to say. And here we would check the number of the revealed ones. So these are the revealed ones. The number of these ones, it should be the same as the number of the all cells minus the bombs. So can a bomb. So these are not bombs. This is not bomb. This is a bomb, and so on. So when we get to the case, then these bombs are all marked down as flags, or basically they are not revealed. They are revealed. Then the game is over and we have won. So here I can say the revealed ones are the squares that are revealed. So I would go inside each row and then on each row inside each column and check to see if that cell is revealed or not. So we have a ACC for accumulator and a row, and for this one, and then return the ACC. But we need to say that ACC is equal to the number of revealed items in that specific row. So row dot reduce, let's say ACC of 2 and each square, and there is another reducer that here we will return the ACC2, and here we say that ACC2 will be if this is revealed then 1, otherwise 0, and we need to instantiate it with 0 and again here with 0. So now this part of the code will show the number of revealed cells across the grid. Then we need to check that if the revealed ones is equal to the number of rows times columns minus the number of mines. If this is the case, then we have won. So we say alert, you won. And we would do the same thing with when we lose. So on the reveal like this, we would grab this part and put it here. This is a bomb, not a bomb, not a bomb, not a bomb. This one also a bomb, bomb. None of these are bomb. This one is a bomb, not this one. None of these. And this is not a bomb. This is a bomb, and yes, we won the game. Fantastic. So yeah, this is the simple code for the game of Minesweeper. I hope you have enjoyed the video. If that's the case, please provide a like, comment, or subscribe to my channel. The code is on the sandbox for you to check, and see you in the next video.